Hello, business calculus students. This is Mr. Lewit. We're going to go over your Chapter 11 quiz in this video lecture. Let me just check one thing here. Okay, I can pause. I will have to pause the video because there's going to be some activity in the household, but hopefully there won't be too many interruptions. Okay. So let's take a look at your Chapter 11 quiz. Problem number 1, find the indicated limit. Note that L'Hopital's rule may not apply or may require more than one application. Okay, so basically, I don't want to spend a huge amount of time on L'Hopital's rule because the application problems later on in the quiz are definitely more challenging. So I'm going to go through the first 5 or so problems a bit quickly, okay? Let me get my marker ready, 1 second. My screen writing tool or my virtual marker. Okay, where did I put it? It's right here. Okay. Okay, fantastic. Okay. So we could try L'Hopital's rule, but, well, first of all, L'Hopital's rule makes more sense when the limit is taken at 0. And here you can see that the limit is not taken at 0, it's taken at infinity. Right over here, as x goes to infinity. So here, I might argue that L'Hopital's rule is not the best way to solve this problem anyway. What I recommend doing, 1 second, let me let me move this window to the side a little bit. What I would recommend doing is just using Mathematica's built-in limit function, okay, which will make the problem so much easier. 1 second, let me just move that over a little bit. Okay, so here's Mathematica. I have the Mathematica window, limit, and remember the software is case sensitive, so if you begin the function's name with a lowercase letter, it's not going to work. All function names in Mathematica begin with an uppercase letter, okay? User-defined functions and user-defined variables can begin with lowercase letters, but all of the built-in commands and built-in functions always begin with a capital letter. So limit 1 plus e to the power negative x divided by 16 plus 5 times x squared as x goes to infinity. Okay, now before I press shift enter, let's try to intuitively understand what's actually happening in this problem. So you can see there's an exponential expression here, e to the power negative x, and as x becomes very, very, very large, this expression is going to become 0. Now, you can also see in the denominator, excuse me, in the denominator we have the expression 16 plus 5x squared. Now, as x squared becomes increasingly larger, this entire expression, 16 plus 5x squared, becomes increasingly larger. So what happens is we're taking the limit of this fraction where the numerator gets closer and closer to the number 1, but the denominator becomes arbitrarily large as x becomes arbitrarily large. So what's going to happen to the value of the fraction? Well, the value of the fraction will tend towards 0. So we say that the limit of the entire expression has to be 0. Let's see if the computer agrees with us. Okay, it's true. The limit is 0, which intuitively makes sense. So the answer is simply going to be option A, or choice A. The limit of the expression is 0. And your input is correct, score 100%. So right over here, Pearson seems to agree with me. Okay, let's move on to the next problem. And like I said, guys, let's move quickly through the first 5 problems because the problems at the end are, I think, a little bit more challenging. So I'm going to go through these a little bit quickly. Okay, so here we have the limit 4 times e to the power negative x divided by 1 plus 7 times e to the power negative x. And you can see, oh, I'm sorry, and then we have the logarithm. This is, traditionally it's ln, but in Mathematica it's capital Log. Okay, capital Log. As x goes to infinity. I believe the answer should be 4, but let's see if the computer agrees with me. Oh, I'm sorry, 4/7. 4/7, because you have the 7 in the denominator. Okay, so yeah, the answer should be 4/7, or 4/7. So let's see if that's true. Okay, that is correct. And let's move on to the next problem. Okay, so here you have a one-sided limit. So we have the expression x times the natural logarithm of x to the power 2600. What is the limit as this expression goes to 0 from the right side? So this is a directional limit. This is a one-sided limit. And again, we can use the software advantageously to solve this problem. So, okay, limit x times the natural log of x to the power, to the power of 2600. X goes to 0, and we're going to say that the direction is 1. The direction is 1, meaning that we're approaching the limit from the right-hand side, from the right side of 0. And the answer is simply 0. Okay, so again, Pearson agrees with my answer. If I have a question about using a function in Mathematica, what I could do is simply type 2 question marks, the name of the command, and then Shift-Enter. I have a choice here. If I click on Local, then I launch the local documentation for the function. If I click on Web, then I launch a browser that will then take me to the online documentation that explains more about this particular function in Mathematica. Let's just click on Local. I'm going to launch the local documentation for this particular function. Local. Okay. Details and options. Let's click on Details and Options. Okay, so as you can see over here, limit as x goes to a certain, x star is simply a number. When they write x star, it's actually just a regular number. The limit as x goes to x star, and then plus means the limit from above. And right over here, limit, excuse me, the limit as x goes to x star minus, that means the limit from the left side or limit from below. We're not going to worry about this one. This refers to the limit in the complex plane. So we're not doing complex analysis in this course, so it's not something you need to worry about. So limit from below and limit from above. However, I prefer the options. Let me see, here we go. We're direction. Okay, directions to approach the limit point. So if I click on directions, from below is one option. Well, direction refers to the direction in which you are approaching the limit. So from below really means from the left side of the limit. From above means from the right side of the limit. Direction two-sided, this is the default. The default option for direction is two-sided. And I believe, let me see, I think I saw this somewhere. Okay, possible settings for direction include, so these are the different options. Possible settings for direction include reals or two-sided from both real directions, which I believe is the default, from above or -1 from above or larger values, from below or +1 from below or from below or smaller values. So actually, I stand corrected. So if you're figuring out the right-sided limit, which is from above, then the setting for the direction option should actually be -1. Although I don't think it's going to affect the outcome of this problem. Let me see. If we use the option -1 for the direction, I think the answer is still going to be 0. Yeah, it's still going to be 0. So it didn't affect the answer for this particular problem. Okay. So that's simply how this function has been designed in Mathematica. So direction arrow -1 simply means that you're approaching the limit from the right side of, in this case, 0. You're approaching, you want to know how the function behaves on the right side of the limit, which is 0, as x goes to 0. Okay, so let's see if Pearson accepts this answer. Your input is correct, score 100%. Okay, terrific, so that's the correct answer. Find the limit. Assume that n is a positive integer greater than 1. So in this particular case, we have n to the power x divided by the square root of x. I don't even think we really need to use Mathematica for this, because just think about it. N to the power x, unless n is 1, but we're assuming here that n is some positive integer greater than 1. 2 to the power x, 3 to the power x, 10 to the power x. It says here, assume that n is a positive integer greater than 1. So this particular function grows extremely fast. The square root of x does not. This function does increase, but it increases rather slowly. Whereas the numerator function, the function in the numerator could be 2 to the power x, 10 to the power x, 100 to the power x. Remember that n is any integer greater than 1. Well, these functions grow extremely fast. So if you have a function in the numerator that grows much, much faster than the function in the denominator, then as x goes to infinity, the entire expression goes to infinity. So the limit at infinity is simply infinity. So the choice should be C. And that is correct. Your input is correct, score 100%. Okay, so that was pretty simple. Or we could use Mathematica to confirm what we already understand intuitively. Limit n to the power x divided by the square root of x as x goes to infinity. Now here the computer may give us a hard time, and I'm going to explain why. Okay, conditional expression. We're getting a conditional expression here because Mathematica does not know that n is an integer and it has to be greater than 1. So what I can do here is simply add an assumption, okay, n must be greater than 1. I don't think I need to specify that n is an integer, because even if n is not an integer, as long as n is greater than 1, the function will increase very rapidly to infinity. So let's see if that works. Okay, hold on 1 second. Okay, sorry about the interruption. Let's get back to the problem. Okay, so yeah. So assuming that n is greater than 1, and I should also include the assumption that n is an integer, because that's what is stated in the problem, but it's really not necessary to get the right answer in this case. Assuming n is greater than 1, the limit of this entire expression as x goes to infinity is simply infinity. Okay? And, that is correct. Okay, so here, we could use L'Hopital's rule, but actually I don't think it's necessary. Again, let's use some basic intuition about how these functions behave. Now, x to the power 14,000 looks extremely big. However, e to the x, this function in the denominator, this function grows much, much, much faster than the function in the numerator. So what happens when your denominator is very, very big and your numerator is very, very small? Which will eventually happen for extremely large values of x. Well, when that happens, the limit is simply going to be 0. And that is correct. Okay, now begin the really challenging problems here. Problem number 6. A company manufactures and sells X cell phones per week. The weekly price, demand, and cost equations are given below. Okay, so the price demand equation is 400 minus 0.5x, where x is the number of cell phones that are manufactured and sold each week. The cost of x is 25,000 plus 135 times x. What price should the company charge for the phones, and how many phones should be produced to maximize the weekly revenue? What is the maximum weekly revenue? Okay, so here we have to, let me shrink this down a little bit. Excuse me. It's a little bit of a yawn. Okay, so I'm not yawning because the problem is boring. It's actually very interesting. I'm yawning because it's a sleepy Saturday afternoon. Okay, the company, so let's see, what should we do here? So we have to remember that revenue is going to be x times p. X times p, where, let me see here, 1 second. P is the price demand equation. So revenue is going to be x times p. Here, let me move this a little bit so I can kind of see what I'm doing here. Okay, so p of x is equal to 400 minus 0.5 times x. I cannot use capital C in Mathematica. It's a reserved variable name. But I can use lowercase c. C of x is equal to 25,000. I did not type that comma, by the way. Mathematica typed the comma for me because of how I formatted my copy of the software. And I think we've been through this discussion already. So I feel no need to repeat myself again here. Cost of x is equal to 25,000 plus 135 times x. The revenue function, revenue as a function of x, is equal to simply x times p of x. Now here, okay, so here I'm asking what price should the company charge for the phones and how many phones should be produced to maximize the weekly revenue. So I have to maximize revenue. Okay, well, let's maximize revenue. How do you do that? You take the derivative and you set it equal to 0. Well, first, why don't we take a look at this function? What does it look like? Let's go up to 1,000. Okay. So actually, I don't even need to go up to 1,000 in my graph. I could just stop at 800. It looks to me like the maximum revenue occurs here when x is equal to 400. So let's see if that's actually true. Let's draw that picture. Graphics, line, 400, 0, and 400, I don't know, let's go up to 90,000. Oops, 1 second. Close the line wait a minute. Oh, no wonder I didn't, okay, close the line function, close the graphics, close the show function. Okay, so it looks to me like the maximum occurs right over here when x is equal to 400. We could check and see if that's true. Derivative of the revenue function of x with respect to x, when x is 400, it should be 0. Okay, which means this is a maximum or a minimum. We can see from the graph it's a maximum. It can't be a minimum. Okay, so the company should produce, the answer is, the company should produce 400 phones each week at a price of, well, let's see, P of 400 is equal to $200. Okay, that's each phone will cost $200. And the maximum weekly revenue is going to be, well, that's easy. Revenue of 400 is equal to $80,000. Oh, 1 second. 1, 2, 3. Okay, $80,000. Part B, what price should the company charge for the phones and how many phones should be produced to maximize the weekly profit? What is the maximum weekly profit? So we have to remember the definition of the profit function. The profit function is equal to the revenue function minus the cost function. The revenue function minus the cost function. Okay, so now we have to maximize this. Well, let's take a look at this function. Let's do a graph. X goes from 0 to 800. Okay, so here you can see from the graph we can't go as far as 800 because if we do, we're going to end up with a negative profit, which doesn't make much sense. Why don't we just go to 400? Let's go to 400. Maybe a little bit beyond 400. Okay, so it looks like the maximum is somewhere between 250 and 300. How do we figure it out? Well, let's find the derivative. The derivative of the profit of x with respect to x, and we're going to set that equal to 0. And then let's figure out what is x. X is 265. X is 265, which makes sense. Let's draw that line in the picture. Graphics, line. So 265, negative 25,000, and 265 up to 15,000. So as you can see, the maximum point, the top point, seems to occur right over here. Okay, right over here when X is equal to 265 cell phones per week. All right, so the company should produce 265 phones each week at a price of, let's find the price, P of 265. It's $267.50, $267.50. And the maximum weekly profit is going to be profit of 265, $10,112.50. $10,112.50. So let's see if Pearson accepts these answers. Okay, your input is correct, score 100%. Okay, fantastic. So hopefully none of this is like super difficult for anybody. If you did the homework, you know, everything I'm showing you right now, really you should be okay with it. You should understand what I'm doing. All you really have to remember for this problem is that the profit is always equal to the revenue minus the cost. Revenue is always going to be X times your P function. P is the price function. And to find the maximum and minimum points, you realize you have to set the first derivative equal to 0. If it's a maximum, the second derivative at that point is negative. And if it's a minimum, the second derivative at that point is positive. So hopefully none of this is difficult, because if you've been doing the homework, all of this should be as easy as apple pie. Okay? So, and we did check that. Okay. This is very similar. Let's do number 7. Okay, 1 second. A company manufactures and sells X television sets per month. The monthly cost and price demand equations are cost as a function of X is equal to 73,000 plus 80X. And the price demand equation or price demand function is equal to 200 minus X over 30, where X is defined on the interval from 0 to 6,000. Find the maximum revenue, that's part A. Part B, find the maximum profit, the production level that will realize the maximum profit, and the price the company should charge for each television set. And then finally, part C, if the government decides to tax the company $4 for each set it produces, how many sets should the company manufacture each month to maximize its profit? What is the maximum profit? What should the company charge for each television set? Okay, so let's go through the problem step by step. Let's see. Okay. So the first step is let's define our functions, okay? So C of X is equal to 73,000 plus 80X. Let me move this over a little bit so I can see the entire problem. Okay, shift enter, and then P of x is equal to 200 minus x over 30. Okay. And let's see, revenue. Revenue of x is simply equal to x times P of x. And this is true for every single problem, for every single math problem in business calculus. And then, of course, my profit function is equal to revenue of x minus the cost of x. Profit with taxes of x. This is a little more complicated. This is going to be, the government decides to tax the company $4 for each television set it produces. So this is actually going to be the same as profit of x, but for each television that you make, you're losing $4 in taxes. So minus 4x. Okay, I think we have all the functions that we need to solve this particular problem. So let's maximize the revenue. Let's maximize the revenue. Let's see, derivative. The derivative of the revenue function of x with respect to x. And let's set that equal to 0. Okay, that's going to be 3,000 television sets. Now let's make sure that the second derivative is really negative at that point. It should be, but let's just check, and then we know for sure we have a maximum point. So the derivative of revenue of x, we want the second derivative, where x, okay, is 3,000. This should be a negative value. It is a negative value, which means that we have a maximum point. The maximum revenue is, and then we simply have to find that maximum revenue. If we're making 3,000 television sets, our maximum revenue is $300,000. Let's see, 1, 2, 3. Okay. What is the maximum profits? Derivative of profit of x with respect to x is equal to 0. Solve. What is x? X is 1,800. Let's make sure the second derivative is negative at that point. Derivative, profit of x, I want the second derivative when x is 1,800. Okay, terrific. So it's still negative. Yeah, so that means we do have a maximum rather than a minimum. Okay, so when x is 1,800, so this would be 1,800 television sets. The maximum profit is profit of 1,800. That's $35,000. And each one should be sold for P of 1,800 for $140. $140. When each set is taxed at $4 per television set, the maximum profit is, okay, so derivative of profit with taxes of x with respect to x. Oh, sorry, hold on 1 second. Yeah, with respect to x is equal to 0. Solve. What is x? 1,740. Let's make sure that the second derivative is really negative, because otherwise we have an issue. Second derivative should be negative. Oh, 1 second. Bad syntax. Okay, there we go. Much better. When x is 1740. Okay, so that works out just fine. 1,740 television sets were manufactured. The maximum profit is profit with taxes of 1740. That's $27,920. $27,920. Oh, sorry, this should be like $27,920. And that's going to be P of 1740, $142. Okay, your input is correct, score 100%. Okay. Okay, number 8. Number 8. The table contains price, demand, and total cost data for the production of extreme cold sleeping bags, where P is the wholesale price in dollars of a sleeping bag for an annual demand of X sleeping bags, and C is the total cost in dollars of producing X sleeping bags. Complete parts A through C below. Let's see what we have here. Part A, find a quadratic regression equation for the price demand data using X as the independent variable. Round the constant to 4 decimal places as needed. Round all other values to 6 decimal places as needed. Okay. There are many different ways of doing this. I'm going to show you the easiest way to do this. All right, there is a way you can do this in Mathematica, and it'll make your life much easier. So we have X. Okay, demand is 950, demand is 1,200, 1,900, and 2,100. Price is 240, 210, 160, 125. And then finally, C, remember I cannot use capital C in Mathematica because that symbol is reserved for other things. But I can use lowercase c. C, or cost, is 130,000, 150,000, 180,000, 200,000. So I need to create a quadratic regression equation for the price demand data. Okay. For the price demand data. So here's what I'm going to do. I'm going to call this XP table. I'm going to make up a letter. I happen to like the letter K. P of K. P of K. K goes from 1 to 4. Why am I going from 1 to 4? Because each of these lists contains 4 numbers. Shift Enter. Okay. So all I did was I paired up my X and P lists. So 950, 240, 1200, 210, 1900, 160, 2100, 125. And then quadratic quadratic equation. Now, the thing is, I can't use x as my variable because I'm using it right over here. So I'm going to use another variable name. I'm going to call it, well, I could call it capital X. I could use capital X. So quadratic is equal to linear model fit my xp data x squared x1, because that's the form of a quadratic. My variable is x, capital X, not small x, because I'm using small x right over here. And let's see. Okay. So what is that going to be? Quadratic of x. Oh, wait a minute. Oh, I see. Okay, this is not quite what I want. So I have to use another variable. Quadratic of large X. Okay, fantastic. So I'm going to round everything to 6 decimal places. Number form. Infinity 6. Traditional form. Okay. So it says here, round the constant to 4 decimal places, round up all other values to 6 decimal places. Okay, so we're going to have negative 0.000017x squared, negative 0.040052x, and this number has to be rounded to 4 decimal places. So then that would be 289.4629. 289.4629. Then it tells me find a linear regression equation for the cost data using x as the independent variable. Find a linear regression equation for the cost data using x as the independent variable. So I'm going to do the same thing as before. xc is equal to table xk, where k goes from 1 to 4. My linear function is equal to linear model fit my xc data, capital X1. My variable is large X or capital X. Okay. And then number form, linear of X. Give me all the digits to the left of the decimal point. Give me 6 digits to the right of the decimal point. So that's going to look like let's see, 55.961406 times x. Oh, round to 3 decimal places is needed. Ugh. Okay, Pearson's going to drive me crazy with their directions. Round to 3 decimal places is needed. So that's going to be 55.961 times x plus 78,959, 78,959.338. Round to 3 decimal places is needed. What is, part C, what is the form of the equation for profit? Write the profit function in terms of the variables from the table, x, p, and c. Well, that's simply going to be x times p minus c. That's your profit, x times p minus c. What is the maximum profit? Okay, so for this one, what I would recommend doing, let me see. So for this one, what I'm going to do is this. Let's figure out our table. xk times pk minus ck, where k goes from the integers 1 to 4. 1 to 4. So we can see that the maximum profit, according to the table, has to be $124,000. $124,000. That's going to be the maximum profit. Okay, so all I did was I took, 950 times 240 minus 130,000. 1,200 times 210 minus 150,000. 1,900 times 160 minus 180,000. 2,100 times 125 minus 200,000. So the maximum of that is 124,000. So that is $124,000. What is the, now let me check one thing, hold on, the wholesale price. Excuse me. The table contains price, demand, and total cost data for the production of extreme cold sleeping bags, where P is the wholesale price in dollars of a sleeping bag for an annual demand of X sleeping bags, and C is the total cost in dollars of producing X sleeping bags. Complete parts A through C below. Okay, so this last question is a little weird. The wholesale price per extreme cold sleeping bag. Well, the wholesale price per extreme cold sleeping bag should be charged to realize the maximum profit is, well, if the maximum profit is here in the third row, I would assume, oh, I see. I would assume that, the profit I should, no, I'm sorry, not the profit, the price that I should charge per sleeping bag, the price that I should charge per sleeping bag would be $160. So if the maximum profit is $124,000, if the maximum profit is $124,000, which appears in the third row of my table, remember, $124,000 is 1,900 sleeping bags times $160 for each sleeping bag minus $180,000 is the cost to produce 1,900 sleeping bags. Then $160, the wholesale price per extreme cold sleeping bag that should be charged to realize the maximum profit should be $160. I have a feeling it may not like this last answer. Okay, so Pearson is telling me my score is 87.5% on this particular question, which means that there is one answer that it does not agree with. There is one answer that it does not agree with. Let me see something. Profit of X, yeah, I'll use large X, is equal to the revenue Well, now this is tricky. Hold on one second. So my revenue function for this particular problem, hold on one second. Okay, so for this problem, my revenue function is going to be x times quadratic of x. And the reason I say quadratic of x is because that gives me this particular function right over here. Okay, p is a function of x, and I named that quadratic of x. Okay, so then here I'm going to have my cost function, and that's going to simply be linear x, because remember that's what I called this function right over here, where c depends upon x. So then my profit function is going to be revenue of x minus cost of x. Okay, something happened. Why? Hold on one second. There is something wrong here with the definition of my function. Hold on a second. Wait a second. Wait. Because this part right over here should not be happening. This is very strange. Quadratic of x. That looks good. Oh, wait a second. Linear of x. Yeah, there's something, this list right over here, this should not be happening. So there is a problem. Hold on one second. I'm just going to copy these out of the homework question, actually. So 1 second. So yeah, that's very strange that that's happening. Hold on 1 second. Why am I getting, okay, hold on. The computer is doing something a little bit strange. Hold on 1 second. So if I were to do normal, linear of x, normal, quadratic of x. All right, let me try that. Because that should not be happening. Okay, so profit of x is equal to, hold on a second. So this will be normal. This will be normal, quadratic of x. This will be normal, linear of x. So the computer, okay, Mathematica is giving me these weird answers. So what I'm going to have to do, because it's not, Okay, now I see. Okay, I don't like that Mathematica is doing that. Okay, so we're going to erase these definitions. We're just going to erase these definitions. Okay. So quadratic of x, because it's not giving me the type of function that I can work with. So the revenue function, revenue of x, is equal to x times 289. I'm just going to copy this by hand, guys. 289.4628975465 minus 0.0400520158872225 times x minus 0.00035627742122 times x squared and then my cost function it's very strange that it's doing that. Huh, very weird. Okay. It seems to accept a real number, but okay, I'm just going to copy that by hand. So my cost function is equal to 78,959.338 33838 plus 55.961405926947 times x. And then my profit function is going to be revenue of x minus the cost of x. Yeah, that actually looks pretty good. Okay, that seems to work. So let me just put this here in the definition. Okay, fantastic. Okay. So that should be the profit function. So if I have a profit of, what was my profit? $124,000. Profit of x is equal to $124,000. Solve. And I'm looking for the variable x. And my answer has to be a real number rather than a complex number. Yeah, that is definitely that is definitely a little bit strange. Although actually, hold on one second. This is the one part of the problem that I'm not too sure about. So what I'm going to do is, let's forget about problems 9 and 10. I want you to do them, but they shouldn't be that difficult. You should be able to figure out problems 9 and 10 without my help because they're really not too bad. So I'm just going to skip 9 and 10 and I'm going to submit this. Or actually, maybe we can do them quickly, but I have a feeling Pearson does not like this particular answer. I have a feeling Pearson does not like that answer. So let's move on to question. Let's do 9 and 10 very quickly. A deli sells 320 sandwiches per day at a price of $4 each. A market survey shows that for every 10 cents reduction in the price, 20 more sandwiches will be sold. How much should the deli charge in order to maximize revenue? Okay, so you have here a deli sells 320 sandwiches per day at a price of $4 each. Every time I reduce the price by 10 cents, 20 more sandwiches are going to be sold. So if you think about this, if you think about this, so if I charge $4 for each sandwich, I'm going to sell 320 sandwiches. And if I charge $3.90, then I'm going to sell 340 sandwiches, etc., etc. So how much money are we actually making here? Okay, so let's think about that. I have a function f of x. Okay, so I have a certain amount if x is equal to $4, then I'm going to make $4 times $4 for each sandwich, $4 for each sandwich times 320 sandwiches. Okay. Otherwise, the difference is going to be, so this number has to be 4 or bigger than 4. X has to be equal to 4 or bigger than 4. So if x, actually I should say the price. We'll call this price. Okay, this variable here will be called price. So if my price is equal to $4, then my profit is going to be $4 times $4 per sandwich times 320 sandwiches. Or the difference is P minus 4. The difference is going to be P minus 4. And for every 10-cent reduction in the price, 20 more sandwiches will be sold. Oh, so actually the P is going to have to be less than or equal to 4. P should be less than or equal to 4, okay, because we're going to go down in price. So let me see here. This would actually be 4 minus P. So that's going to be the difference because I'm reducing my price by 10 cents. Okay. And let's see, that's going to be the difference. So 4 minus P. And the ratio will be the difference divided by 0.10. That's going to be the ratio, the difference divided by 0.10. So the difference is going to be 4 minus the amount of money that I'm actually charging for the sandwich. The ratio is the difference divided by 0.10. Okay, so if I decrease the price of the sandwich to $3.90, then the ratio will be 10 cents divided by 10 cents, which is 1, and then I would have 4 minus P times 320 plus 20 times the ratio. So let's see if this actually works. So 4 times 320 is 1,280. What happens if I charge $3.90? Hold on. Oops. This should be a comma. Sorry. Sorry, a semicolon. Let's do that one more time. Okay. So then we would have, one second. Oh, this should be difference. This actually should be difference. Wait a minute. Sorry about that. This value here should be difference. Sorry about that. So $4 a sandwich, 320 sandwiches. That's $1,280. $3.90. Why am I still getting $3.90 of 34? So $3.90 times, if I decrease the price of the sandwich by 10 cents, then I would have 340 sandwiches. This should be 1326. Here, one second. Let me pause the video and try to tweak this because something's going on that's not quite right. Hold on one second. Okay, so I caught my mistake. It was just a foolish mistake. So this value here, remember it used to be ratio. It's p. So this is the function that you should use. So once again, for problem number 9, this is the function you should really use. So one more time. Let me define this again. P is a price. P must be less than or equal to $4. If P is equal to $4, 4 times $4 a sandwich times 320 sandwiches. Otherwise, the difference is going to be equal to 4 minus P. So for example, if P is $3.90, the difference is 10 cents. All right, the ratio is equal to the difference divided by 0.10. Finally, we're going to have P, the price, times 320 plus $20 times the ratio. And I'm assuming, the ratio is going to be an integer because we're always changing the price by 10 cents. Shift, enter. So for example, for $4, your profit is going to be $1,280. If I charge $3.90 a sandwich, my profit goes up to $1,326. Why? Because $3.90 times 340 sandwiches is $1,326. Because remember, it says here, every time I reduce the price of the sandwich by 10 cents, I can sell 20 more sandwiches. But at some point, guys, this isn't going to work too well. So let's think about this. How many times does 10 cents go into $4? Okay, 10 cents goes into $1 10 times, so 10 cents goes into $4 40 times. Okay, so what I can do is this, table. Let's see. I want my price. Well, I want my price and the number of sandwiches. So, hold on one second. I'm really looking at the price. Okay, so K is going to be the price, and oops. K goes from $4 to 0 in steps of negative 10 cents. Okay, so let's take a look at this. If I charge $4, here, 1 second. If I charge, okay. If I charge $4, this is going to be my profit. $3.90, this is my profit. $3.80, this is my profit. $3.70, this is my profit. It keeps going up until, when does it start to go down? When does this start, 1 second, when does this start to go down? Because at some point it will actually start to go down. These numbers keep right over here. Right over here. Take a look at this. The maximum here is a profit of $1,568. $1,568. Okay, so one more time, $1,568. And that corresponds to charging people $2.80 for each sandwich. And that will give you your, your maximum profit, okay? So the deli should charge $2.80. $2.80, whoops, 1 second. $2.80 for a sandwich to maximize revenue. Round to the nearest cent as needed. A different market survey, this is part B, a different market survey shows that for every 20-cent reduction in the original $4 price, 10 more sandwiches will be sold. Now, how much should the deli charge in order to maximize revenue? Okay, so this is actually a little bit of a different problem, but it's similar. We can use the same function. We'll just have to change it a little bit. Okay, copy, paste. Let's call this function G. Okay. Let's see, if P is equal to 4 times 320, 4 minus P. Okay, this time we have to divide by 20 cents for this part of the problem. 20 cents. And it says here, a different market survey shows that for every 20 cents reduction in the original $4 price, 10 more sandwiches will be sold. Now, how much should the deli charge in order to maximize revenue? So here we have to divide by 20 cents, and here this would be 10 this time instead of 20. Okay, so that's going to be our function G. 10 more sandwiches will be sold, whereas up here, what was it? It was 20 more sandwiches. So it's very similar. It's a very similar function. Okay, so table K, G of K, K goes from 4 to 0. Now remember, how many times does 20 cents go into $4? Well, 20 cents goes into $1 5 times, so it goes into $4 5 times 4, 20 times. So this will be negative 0.20, table form. Okay, that is not, hold on 1 second. What's wrong here? Why didn't this get defined? Hold on a second. Okay, so there's a problem here. If p is equal to 4, okay, 4 minus p ratio, difference. That's really weird. Why, this function somehow did not get defined. So g of 4. Okay, why didn't this get defined? How strange. This isn't evaluating to anything, so that should not be happening. So 1 second. That's very weird. Difference is equal to, oh, you know what? That's very, very weird. Okay, for some reason, it didn't evaluate my g function. I don't understand why. Copy, paste. Okay, that is really, really weird. It is not, I don't understand why it's not evaluating it. 1 second. So g of p, oh, you know why, because there's no underscore here. Okay, so that was very bad. Actually, there really should be an underscore there too. That's very strange. Okay, so yeah, very, very weird. Okay, so yeah, very, very strange. Okay, so this is my g function, and now if I simply copy and paste that over here, okay, so for 4 sandwiches, let's see, a profit of 1,280. Okay, so everything is really, if I decrease by 20 cents, really my profits immediately start to decrease. So here, the deli really has to charge $4 for a sandwich to maximize revenue. Okay, so here, that was really strange because when you define a function, guys, you do have to use that underscore. That is really important. You do have to define your underscore. So that was a mistake that I made. So here, the reason this didn't work was because I was missing that underscore. Although strangely enough, it did work for F, which is kind of unusual. So if I charge $4 a sandwich, my profit is 1,280. If I go down to $3.80, 12.54, $3.60, my profits start to just decrease immediately. So it really should be $4 a sandwich. Okay, so your input is correct. Score 100%. That looks good. So yeah, just be careful, guys, when you define your functions. So if I were to do this, for example, okay, that's not what I want. I don't want my cursor over there. Hold on 1 second. Let me just delete that. If I have a function, for example, f of x is equal to x plus 2, it doesn't make any sense. Okay, this has to be, right, I need that underscore, and now, okay, it's still here, clear f. So f of x is equal to x plus 2, so now f of 3 should be 5. Okay, you need that underscore. You really do need that underscore. Okay, let me clear global. This clears everything. Okay, let's go to problem number 10. Okay, a car rental agency rents 480 cars per day at a rate of $20 per day. For each $1 increase in rate, 10 fewer cars are rented. At what rate should the cars be rented to produce the maximum income? What is the maximum income? Okay, I'm going to use the same strategy as before. So profit of P, I'm going to use an if statement. Okay, so what is an if statement? You guys should know this. If 5 is bigger than 4, print hello. Otherwise, print goodbye. So, I mean, everyone knows the answer. 5 is bigger than 4, so print hello. That's kind of small, right? That's a small, tiny hello. Okay, but I could make that bigger, but don't worry about it. I could do something like style, font size is 24. That's not what I want. Okay, hold on one second. So let me, that's not quite, oh, I see what's happening. Okay, well, I shouldn't get so obsessive about this. Hold on one second. So style, sorry, font size is 24. 1 second. And print style. Oops, sorry. Font size is 24. Okay. Okay. So 5 is bigger than 4, so we're going to do this. We're going to do this. One second, actually, that should be, okay, why do I have that over there? Sorry about that. And style print, and this should be style. 1 second. Okay. So here we have, if 5 is bigger than 4, we're going to do, print hello. And if 5 is bigger than 7, that's false. Then we have goodbye, okay? So it's pretty simple. Okay. So I'm going to do the same thing to solve this problem. A car rental agency rents 480 cars per day at a rate of $20 per day. For each $1 increase in rate, 10 fewer cars are rented. At what rate should the cars be rented to produce the maximum income? What is the maximum income? So I'm going to do the same thing, guys. F of price is equal to, if the price is equal to $20, if it's equal to $20, then my profits, why don't I just call this profit? Then my profit is going to be 480 times the price. Now, if the price is bigger than that, and this price is going to have to be, price is greater than or equal to $20. If the price is greater than that, okay, if the price is greater than that, for each $1 increase in rate, so again, my difference is going to be equal to price minus 20, semicolon, price minus the 20, okay, And this time I'm just dividing by 1. The ratio is actually the difference divided by 1. But if you divide by 1, there's, the difference is going to be the same thing. The ratio is the same as the difference. So then I'm going to have difference is price minus 20. So 21 minus 20 is 1. 22 minus $22 minus $20 is 2. $25 minus $20 is 5, etc., etc. So then I'm going to have my profit is going to be the price multiplied by 480 minus 10. Oh, sorry. The price is going to be the price times 480 minus 10 times the difference. So if I charge $22, let's say this is $22. 22 minus 20 is 2. 10 times 2 is 20. 480 minus 20 is 460 multiplied by the price. Okay, so that really does make sense. Let's see. So I'm going to have the price. For each dollar increase in rate, 10 fewer cars are rented. So sure, a minus 10 times the difference. So table price, profit of price. The price is going to go from $20 up to, now let's think about it. How many times does 20 go into 480? 24 times. So we could afford a $1 increase 24 times. So 20 plus 24 is 44. Actually, I could even, let me see. I could even go farther than 24, but 480 cars. Hold on one second. You would lose 10 cars. Oh, wait, actually, no. No. This would be 20 plus 48. Sorry, 20 plus 48. 48 plus 20 would give me 68, and then I should have 0. Yeah, at 68, I have 0. So this is going to be, yeah. If you're going to charge, $68 a day, your profit is 0 because you won't be able to sell. You won't be able to rent any cars. So let's take a look at this. Where's the maximum? Where is the maximum? So 9870. Okay, this is bigger. One second. It's not what I want. Okay, hold on one second. Bigger. Okay, so actually, right over here, the profit looks like it keeps getting bigger and bigger. Right over here. This is actually, this right here is the maximum. So if you charge $34, if you charge $34 a day, right over here, that's going to give you the maximum. If you charge less than that, or if you charge more than that, you're going to have less of a profit. You're going to make less money. So in order to make the most profit, in order to make the most money, you would have to charge $34 a day. And if you charge less than that, if you charge more than that, if you charge less than that, your profit goes down. And if you charge more than that, your profit also goes down. All right, so here, 1 second, where was that again? I just lost it. What was it, 35? No, 34. It was $34 a day. Right over here, $34 a day. So this is going to be your max profit. Okay, so that's going to be, the rental agency will earn a maximum income of $11,560 when it charges $34 per day. When it charges $34 per day. Let me go back to this one. Okay, so let's see. That should be correct. Let me submit this. Okay, so the only problem, so Pearson accepted question 1, question 2, question 3, 4, 5, 6, 7, most of 8. Most of 8, 9, and 10. Let's see what happened with problem number 8. So, according to Pearson, okay, this is correct, this is correct, this is correct, this is correct. Okay, this one is not correct. So there's one answer here that Pearson doesn't agree with. You answered 160. Pearson was looking for 192. All right, guys, if you can find the answer to this one, let me know what you did. If no one gets it right, if no one in the class gets it right, then I will give you credit for this particular answer. I'll give you credit for this particular answer. Only that one. Only that one. But let me see here. So, oops, what did I just do? Okay. Okay, I just erased my quiz, but that's okay. So, okay, guys, we've been through this. This was a long video, a little longer than I wanted it to be. You should now know how to do all of the quiz questions. There is a little bit of that issue with problem number 8 at the very end, the very last step. If you do find the right answer, email me, let me know how you got the answer. If no one in the class can figure it out, I'll just give you guys credit for that, not the entire problem, but for the last part of that problem. Okay, and that's it for now. I think this video has gotten long enough, and we will communicate at some point in the future. Take care. Bye-bye.